Hello my dear friends. Welcome to the online lesson on the Geography of Turkey Physical Geography of Turkey course. In today's session, we will delve into the hydrographic features of Turkey's lakes. Turkey is endowed with a diverse range of lakes, each contributing to the country's ecological richness, biodiversity, and sometimes serving as vital water resources. Here are some notable lakes in Turkey. 1. Lake Van. Located in eastern Turkey, Lake Van is the largest lake in the country and the second largest soda lake in the world. It is known for its stunning landscapes, historical sites, and the medieval Armenian church of Akdamar Island situated on its waters. 2. Lake Tuz. Situated in the Central Anatolia region, Lake Tuz is the second largest lake in Turkey and one of the largest hypersaline lakes globally. It is known for its high salt concentration and serves as a significant center for salt production. 3. Lake Beyşehir. Located in the southern part of the Central Anatolia region, Lake Beyşehir is the third largest lake in Turkey. It is recognized for its clear waters, diverse bird species, and the historical Eflatun Pinar, Plato spring, on its shores. 4. Lake Iznik, Lake Iskanya. Situated near the town of Iznik in northwestern Turkey, this lake has historical and cultural significance. It is known for its association with the ancient city of Nicaea and the First Council of Nicaea in AD 325. 5. Lake Agirder. Located in the Isparta province in southwestern Turkey, Lake Agirder is the fourth largest lake in the country. It is surrounded by picturesque landscapes and traditional villages, making it a popular destination for tourism. 6. Lake Sapanca. Positioned in the Sakarya province in northwestern Turkey, Lake Sapanca is a freshwater lake known for its natural beauty and recreational activities. It is a popular weekend getaway for residents of nearby cities like Istanbul. 7. Lake Burdur. Located in the Burdur province in southwestern Turkey, Lake Burdur is one of the country's important wetland areas. It is recognized for its ecological significance and is designated as a Ramsar site. 8. Lake Abant. Situated in the Bolu province in northwestern Turkey, Lake Abant is known for its scenic surroundings, including pine forests and meadows. It is a popular destination for nature lovers and offers various outdoor activities. 9. Lake Guljuk. Located in the Bolu province, Lake Guljuk is a small but picturesque crater lake surrounded by forests. It is a popular spot for hiking, picnicking, and enjoying nature. These lakes contribute to Turkey's environmental diversity, providing habitats for various plant and animal species and offering recreational and economic opportunities. Additionally, some lakes play a role in water management and hydroelectric power generation. The abundance of lakes in Turkey, both natural and artificial, contributes significantly to the country's environmental diversity, water resources, and socio-economic activities. As you mentioned, Turkey is home to more than 120 natural lakes and 555 dam lakes, including smaller mountain lakes. Here's a brief overview of the significance of these lakes. 1. Natural lakes. Turkey's natural lakes are spread across various regions, each with unique ecological characteristics. These lakes contribute to biodiversity, supporting a variety of flora and fauna. Some natural lakes also have historical and cultural significance, attracting tourists and researchers. 2. Dam lakes. The numerous dam lakes in Turkey are primarily created for water storage, irrigation, and hydroelectric power generation. These artificial reservoirs play a crucial role in water management, supporting agriculture and providing a renewable energy source. 3. Biodiversity and conservation. Many of Turkey's lakes, whether natural or dammed, are important for biodiversity conservation. They serve as habitats for various species of fish, birds, and other wildlife. Conservation efforts in and around these lakes contribute to the preservation of Turkey's natural heritage. 4. Water resources. Lakes, especially dam lakes, serve as crucial water reservoirs. They play a role in regulating water availability for agricultural irrigation, industrial use, and domestic consumption. Proper management of these water resources is essential for sustainable development. 5. Tourism and recreation. Several lakes in Turkey, particularly those with scenic landscapes, attract tourists and outdoor enthusiasts. Activities such as boating, fishing, and hiking around these lakes contribute to local tourism economies. 6. Agricultural support. The water stored in dam lakes is often used for irrigation, supporting agriculture in the surrounding areas. This is particularly important for regions where water resources are crucial for crop cultivation. 7. Hydroelectric power. Dam lakes are integral to Turkey's energy infrastructure. Hydroelectric power plants harness the energy from flowing water, contributing to the country's renewable energy capacity and reducing reliance on non-renewable sources. 8. Research and education. Lakes, both natural and artificial, provide opportunities for scientific research and environmental education. Researchers study the ecosystems, water quality, and geological features of these lakes to enhance understanding and promote conservation. Understanding the significance of Turkey's diverse lakes underscores their multifaceted role in the country's ecology, economy, and overall sustainable development. Effective management and conservation efforts are crucial to balance the various demands on these valuable water resources. The Lakes region, South Marmara, Lake Van, and Tuz Lake and their surroundings are distinctive geographical areas in Turkey, each characterized by unique features, landscapes, and cultural significance. Here's a brief overview of each region. 1. Lakes region. The Lakes region, also known as the Galler Bölgesi in Turkish, is located in the western part of Turkey. It is characterized by numerous freshwater lakes, both natural and artificial, contributing to the region's lush landscapes. Some prominent lakes in this region include Lake Agurdur, Lake Beyşehir, and Lake Burdur. The Lakes region is known for its agricultural activities, charming lakeside towns, and diverse ecosystems. 2. South Marmara. South Marmara is a subregion of the larger Marmara region, located in the northwestern part of Turkey. It includes provinces such as Bursa, Beyşehir, and Çanakkale. The region is known for its rich history, cultural heritage, and diverse landscapes that encompass mountains, forests, and coastal areas along the Sea of Marmara. Bursa, one of the major cities in the region, was the first capital of the Ottoman Empire. 3. Lake Van and its surroundings. Lake Van is the largest lake in Turkey and is situated in the eastern part of the country. The lake is known for its stunning landscapes, surrounded by mountains, including the dormant volcano Mount Supan. The historic Akdamar Island on Lake Van is home to the Armenian Akdamar Church. The region has a blend of natural beauty, cultural sites, and historical significance. 4. Tuz Lake and its surroundings. Tuz Lake, or Lake Tuz, is the second largest lake in Turkey and is located in the Central Anatolia region. It is a saline lake, and during dry seasons, its exposed lakebed becomes covered with a layer of salt. The lake is a significant site for salt production and is surrounded by steppe-like landscapes. The nearby city of Aksaray and the Tuz Gölü Basin offer insights into the traditional salt extraction methods. These regions showcase the geographical diversity of Turkey, featuring a mix of lakes, mountains, historical landmarks, and cultural heritage. The Lakes region is known for its freshwater lakes and agricultural activities. South Marmara is characterized by its historical significance and diverse landscapes. Lake Van is renowned for its large and picturesque lakes surrounded by mountains, and Tuz Lake stands out for its unique saline environment and traditional salt production. Each region contributes to the country's overall richness in terms of natural resources, cultural heritage, and economic activities. Freshwater lakes obtain their water primarily from precipitation, surface runoff, groundwater inflow, and inflowing rivers or streams. Here's a breakdown of how freshwater lakes acquire and maintain their freshwater. 1. Precipitation. Rainfall and snowmelt are primary sources of freshwater for lakes. When precipitation occurs over a lake's watershed, the area of land that drains into the lake, water accumulates on the lake's surface. Rainfall directly contributes to increasing the lake's water level. 2. Surface runoff. Water from precipitation that doesn't infiltrate the soil or get absorbed by vegetation becomes surface runoff. This runoff flows over the land and into the lake. The quality of the water in the lake can be influenced by the surrounding land, as runoff may carry sediments, nutrients, and pollutants into the lake. 3. Groundwater inflow. Lakes often receive water from underground sources. Groundwater, which is water stored in soil and rock layers beneath the Earth's surface, can seep into a lake, contributing to its water volume. This groundwater input helps maintain a consistent water supply even during dry periods. 4. Inflowing rivers and streams. Lakes are often part of larger river systems. Inflowing rivers and streams transport water from higher elevations to lower elevations, feeding into the lake. These inflows can significantly impact the lake's water level and quality. 5. Evaporation. Lakes lose water through evaporation, a process where water is converted from liquid to vapor and released into the atmosphere. However, the water lost through evaporation is typically compensated by the inflow of freshwater from precipitation, runoff, and other sources. 6. Outflow. Lakes may have outflow, where water is released from the lake into downstream rivers or streams. Outflow is a critical component in maintaining a balance in water levels and preventing flooding during periods of excessive precipitation. 7. Hydrological balance. The overall hydrological balance of a lake depends on the relationship between water inputs, precipitation, runoff, inflow, and outputs, evaporation, outflow. If the inputs exceed the outputs, the lake gains water, and if the outputs exceed the inputs, the lake loses water. 8. Climate and geography. The climate and geography of the region play a significant role in determining the freshwater availability for lakes. Regions with higher precipitation, lower evaporation rates, and abundant surface runoff are more likely to have freshwater lakes. Maintaining a healthy balance between water inputs and outputs is crucial for the sustainability of freshwater lakes. Human activities, such as urbanization, agriculture, and industrial processes, can impact this balance and lead to changes in water quality and availability. Sustainable water management practices are essential to preserve the ecological integrity of freshwater lakes. A lake has salty water when it contains a high concentration of dissolved salts and minerals. There are several ways in which lakes can become saline, and the specific factors contributing to salinity depend on the lake's geological, hydrological, and climatic conditions. 1. Closed basin lakes. Some lakes are situated in closed basins, meaning they have no outlet to rivers or oceans. Without an outlet, the water that enters the lake stays within the basin. As water evaporates from the lake's surface, it leaves behind salts and minerals, leading to an increase in salinity over time. The Great Salt Lake in the United States is an example of a closed basin lake with high salinity. 2. Geological processes. The geology of the surrounding area can influence the composition of the water in a lake. If the lake is located in an area with salt-rich geological formations, the water may naturally contain elevated levels of salts. Geological processes, such as the dissolution of salt deposits, can contribute to salinity. 3. Connection to saline groundwater. Lakes may be connected to saline groundwater sources. If groundwater with a high salt content feeds into a lake, it can increase the salinity of the lake water. This often occurs in arid regions where groundwater may have accumulated salts from the surrounding rocks. 4. Volcanic activity. Lakes formed in volcanic regions may have elevated salinity due to the presence of volcanic minerals and gases. Volcanic activity can contribute minerals such as sulfur and chloride to the lake water, increasing salinity. 5. Human activities. Human activities, such as irrigation, industrial discharges, and mining, can introduce salts and pollutants into lakes, leading to increased salinity. Agriculture, in particular, can contribute to salinity if irrigation water contains dissolved salts that accumulate in the soil and eventually reach the lake. 6. Evaporation and concentration. Lakes in arid or semi-arid climates may experience high rates of evaporation. As water evaporates, the concentration of salts in the remaining water increases, leading to higher salinity. The Dead Sea in the Jordan Rift Valley is an example of a lake with high salinity due to intense evaporation. 7. Climate change. Changes in climate patterns, such as increased temperatures and altered precipitation, can influence a lake's salinity. Changes in evaporation rates and the balance between water inputs and outputs can impact the concentration of salts in the water. Understanding the specific factors contributing to the salinity of a lake is essential for managing and mitigating potential environmental impacts. High salinity can affect the lake's ecology, water quality, and usability for human activities. Management strategies may include monitoring water sources, implementing sustainable agricultural practices, and protecting the lake's watershed. The reduction of water levels in lakes during the summer, often associated with drought conditions, is a recurring phenomenon in many regions, including Turkey. Several factors contribute to this seasonal variation in lake water levels. 1. Seasonal climate patterns. Turkey experiences distinct seasonal climate patterns, with summers often characterized by higher temperatures and reduced precipitation. During the summer months, evaporation rates tend to increase, leading to a net loss of water from lakes. 2. Drought conditions. Droughts, which are prolonged periods of abnormally low precipitation, can exacerbate the reduction in lake water levels. Insufficient rainfall and reduced inflow from rivers and streams during droughts contribute to the overall water deficit. 3. Increased evaporation. Higher temperatures during the summer result in increased evaporation from the lake's surface. This natural process causes water to be lost to the atmosphere, particularly in regions with arid or semi-arid climates. 4. Water extraction for agriculture and urban use. Human activities, such as agricultural irrigation and urban water consumption, can contribute to the reduction of lake water levels. Increased water demand during the summer months may lead to the extraction of water from lakes for various uses. 5. Hydrological changes. Alterations in the natural flow of rivers and streams that feed into lakes can impact water levels. Dam construction, water diversion projects, and changes in land use can influence the hydrological balance, affecting the amount of water reaching the lakes. 6. Climate change impacts. Long-term climate change can influence precipitation patterns and temperature extremes. Changes in climate may lead to more frequent and severe droughts, impacting water availability in lakes and exacerbating water level reductions. 7. Management practices. Human management practices, including water reservoir operations and release schedules, can influence lake water levels. In some cases, water authorities may intentionally reduce lake levels for downstream water supply, hydropower generation, or flood control purposes. 8. Environmental consequences. Reductions in lake water levels can have environmental consequences, affecting aquatic ecosystems, biodiversity, and water quality. Lower water levels may concentrate pollutants, alter habitats, and impact the reproductive cycles of aquatic organisms. Mitigating the impact of reduced water levels in lakes during summer droughts involves a combination of sustainable water management practices, conservation efforts, and adaptation strategies. These may include the implementation of water-saving measures, the promotion of efficient irrigation practices, monitoring and regulating water extraction, and enhancing resilience to climate change impacts. Lake Van. Lake Van is recognized as Turkey's deepest lake, with a maximum depth of approximately 451 meters, 1,480 feet. It is located in the eastern part of the country and is the largest lake in Turkey. Lake Van is situated in a tectonic basin and is known for its scenic landscapes, historical sites, and islands, including Akdamar Island with the Akdamar Church. Tuzgolu, Lake Tuz. Tuzgolu, or Lake Tuz, is identified as Turkey's shallowest lake. It is a saline lake situated in the Central Anatolia region. During the dry season, the lake's depth can decrease to as little as 1 to 2 meters. Lake Tuz is renowned for its high salinity, and its exposed lakebed often becomes covered with a layer of salt, making it one of the largest salt flats in the world. These two lakes exemplify the diverse characteristics of Turkey's lakes, showcasing variations in size, depth, and salinity. While Lake Van represents a deep, freshwater lake with cultural and historical significance, Lake Tuz demonstrates the unique features of a shallow, saline lake with economic importance for salt production. Seas and lakes are both bodies of water, but they have distinct characteristics that differentiate them. Here are some key differences between seas and lakes. 1. Size. Seas are typically larger bodies of saltwater that are part of the interconnected global ocean. They can vary in size, ranging from small seas, like the Sea of Marmara, to large seas, like the Mediterranean Sea. Lakes are generally smaller bodies of freshwater, and they can vary in size from small ponds to large expanses such as the Great Lakes in North America. 2. Saltwater versus freshwater. Seas are composed of saltwater, and their salinity is generally higher than that of freshwater bodies. The salt content in seas comes from the connection to the ocean and the evaporation of water. Lakes contain freshwater, and their water is generally not as saline as seawater. The primary sources of water for lakes are precipitation, runoff, and inflowing rivers. 3. Connectivity. Seas are often interconnected with the global ocean. They are typically partially enclosed by land but have open connections to the ocean. Lakes are usually landlocked, meaning they are surrounded by land and do not have a direct connection to the ocean. Some lakes, however, may be connected to rivers or other water bodies. 4. Depth. Seas are generally deeper than lakes. The average depth of seas can vary, and some seas, like the Mediterranean, can have significant depths. Lakes can have varying depths, but they are generally shallower than seas. Lake Baikal in Siberia, for example, is one of the deepest lakes globally. 5. Formation. Seas are part of the Earth's oceans and are formed through tectonic processes, such as the opening of ocean basins or the subduction of tectonic plates. Lakes can be formed through various geological processes, including glacial activity, tectonic activity, volcanic activity, and the damming of rivers. 6. Usage. Seas have been historically significant for trade, transportation, and fishing. They are often used for international shipping and have strategic importance for coastal regions. Lakes are used for various purposes, including recreation, water supply, fishing, and sometimes transportation. They are often important for local ecosystems and communities. Understanding these differences helps provide insights into the unique characteristics and roles that seas and lakes play in the Earth's geography and ecosystems. Most of our lakes are located at significant elevations above sea level. For instance, Hozapin, Aktas, in Ardahan is positioned at an impressive altitude of 1,798 meters, while Lake Van reaches a height of 1,646 meters. These elevations contribute to the unique and picturesque landscape surrounding these lakes, showcasing Turkey's diverse geographical features. The key factors influencing the chemical composition of lake waters include: 1. Geological setting. The geological characteristics of the lake's watershed and basin influence the composition of the water. The underlying rock types and soil minerals in the surrounding area can contribute various ions and elements to the lake water. 2. Topography and landscape. The topography of the landscape, including the slope and shape of the surrounding land, affects the flow of water into the lake. Steeper terrain may lead to faster runoff, potentially carrying more sediments and minerals into the lake. 3. Climate and precipitation. Climate plays a crucial role in determining the amount and frequency of precipitation. Rainfall and snowmelt contribute freshwater to the lake, influencing its volume and diluting or concentrating the chemical constituents. Regions with higher rainfall may have more dilute lake waters. 4. Temperature. Water temperature affects the solubility of gases and minerals in the water. Warmer temperatures can enhance the chemical reactions and dissolution of minerals, potentially impacting the water's composition. 5. Vegetation and organic matter. Aquatic plants and organic matter in and around the lake can influence the chemical properties. Decomposition of organic material contributes to nutrient cycling, affecting nutrient concentrations such as nitrogen and phosphorus. 6. Human activities. Anthropogenic influences, such as agriculture, industry, and urban development, can introduce pollutants and alter the chemical balance of lake waters. Runoff from fertilized fields, industrial discharges, and wastewater can lead to increased nutrient levels and contaminants. 7. Ecosystem interactions. The interactions within the lake's ecosystem, including the activities of microorganisms, algae, and aquatic organisms, play a role in nutrient cycling and chemical transformations. For example, biological processes can influence the concentrations of dissolved oxygen and carbon dioxide. 8. Water residence time. The length of time water remains in the lake, residence time, affects the accumulation and removal of dissolved substances. Lakes with longer residence times may experience more chemical transformations and interactions. 9. Water source. The source of water, such as inflowing rivers, groundwater, or precipitation directly onto the lake, influences the initial composition of the water. Different water sources may introduce distinct chemical characteristics. 10. Hydrological processes. Hydrological processes, including evaporation, water exchange with the atmosphere, and outflow, impact the concentration of dissolved substances in the lake. Evaporation, for example, can lead to the concentration of minerals in the remaining water. Lakes serve a variety of important functions and provide numerous benefits to both natural ecosystems and human societies. The uses of lakes are diverse and can be categorized into several key aspects. 1. Water supply. Lakes are crucial as sources of freshwater for domestic, agricultural, and industrial purposes. Many communities rely on lakes as reservoirs to supply drinking water and support irrigation for crops. 2. Recreation and tourism. Lakes are popular destinations for recreational activities, including boating, fishing, swimming, hiking, and camping. The scenic beauty and tranquility of lakes attract tourists, contributing to local economies through tourism-related businesses. 3. Biodiversity and ecosystem support. Lakes are ecosystems that support a wide range of plant and animal species. They contribute to biodiversity by providing habitats for fish, waterfowl, amphibians, and various aquatic organisms. Healthy lake ecosystems also play a role in maintaining ecological balance. 4. Hydropower generation. Some lakes are used for hydropower generation. Dams built on lakes can harness the energy of flowing water to produce electricity, contributing to renewable energy sources. 5. Flood control. Lakes can act as natural buffers against flooding. They absorb excess water during periods of heavy rainfall or snowmelt, helping to prevent downstream flooding in river systems. 6. Navigation and transportation. In some regions, lakes serve as navigable waterways, supporting transportation of goods and people. Lakes with ports or harbors facilitate shipping and trade activities. 7. Agriculture. Lakes contribute to agriculture by providing water for irrigation. In certain regions, farmers rely on lakes to supplement water resources for crop cultivation. 8. Waste treatment and nutrient cycling. Lakes play a role in nutrient cycling and the natural treatment of organic matter. Microorganisms and plants in lakes can help break down pollutants and improve water quality. 9. Cultural and spiritual significance. Lakes often hold cultural and spiritual importance for local communities. They may be associated with traditional rituals, ceremonies, or myths, contributing to cultural identity. 10. Scientific research. Lakes are valuable subjects for scientific research. Ecologists, limnologists, and other researchers study lakes to understand ecological processes, water quality dynamics, and the impacts of human activities on aquatic ecosystems. 11. Climate regulation. Lakes can influence local climate patterns. They may moderate temperatures in surrounding areas, providing cooling effects during hot periods and influencing precipitation patterns. The classification of lakes can be based on various criteria, providing insights into their diverse characteristics. Here's a detailed explanation of how lakes can be classified based on origin, size, depth, and geographical location. Number 1. Origin. Tectonic lakes. Description: formed in tectonic basins or depressions due to movements in the Earth's crust. Glacial lakes. Description: created by the melting of glaciers, often leaving behind depressions or moraine-dammed basins. Volcanic lakes. Description: formed in volcanic craters or calderas as a result of volcanic activity. Karst lakes. Description: developed in karst landscapes with soluble rock formations, where sinkholes or depressions fill with water. Alluvial or fluvial lakes. Description: created by the deposition of sediments by rivers or streams, forming basins. Landslide or rockslide lakes. Description: result from landslides or rockslides that block rivers or streams, creating impoundments. Anthropogenic or reservoir lakes. Description: man-made lakes formed by the construction of dams for various purposes, including water supply, hydropower, or flood control. Number 2. Size. Macroscopic or large lakes. Description: lakes with extensive surface areas and larger volumes. Mesoscopic or medium-sized lakes. Description: lakes with moderate surface areas and volumes. Microscopic or small lakes. Description: lakes with relatively small surface areas and volumes. Example: a small mountain lake. Number 3. Depth. Oligotrophic lakes. Description: nutrient-poor lakes with clear water and low biological productivity. Mesotrophic lakes. Description: moderately productive lakes with moderate nutrient levels. Eutrophic lakes. Description: nutrient-rich lakes with high biological productivity and potentially murky water. Number 4. Geographical location. Endorheic or closed basin lakes. Description: lakes without an outlet, where water does not flow into an ocean or sea but is retained within the basin. Meromictic lakes. Description: lakes with distinct layers of water that do not mix, typically due to differences in temperature and salinity. Cryptodepression lakes. Description: lakes that are not easily visible on the landscape due to being situated below ground level. Playa lakes. Description: temporary lakes or wetlands found in arid or semi-arid regions, often filling during rainy seasons. Understanding these classifications helps in appreciating the diverse nature of lakes globally, each category reflecting specific geological, hydrological, and environmental conditions. Lakes in Turkey can be classified based on their formation processes. The formation of lakes is influenced by various geological, climatic, and hydrological factors. Here are some common types of lakes in Turkey based on their formation. 1. Tectonic lakes. Description: tectonic lakes are formed in tectonic depressions or basins created by the Earth's crustal movements. These lakes are often deep and may be associated with fault lines or rift zones. Example: Lake Van is a notable tectonic lake in Turkey, situated in a tectonic basin in the eastern part of the country. 2. Glacial lakes. Description: glacial lakes are formed by the erosive action of glaciers during the Pleistocene epoch. Glacial movement carves out depressions that fill with meltwater, forming lakes with distinctive features. Example: some lakes in northeastern Turkey, such as Lake Sldr, have glacial origins. 3. Landslide or rockslide lakes. Description: landslide or rockslide lakes are created when large masses of rock or soil slide into a valley or basin, blocking rivers or streams. The dammed water forms a lake behind the debris. Example: Lake Karagöl in northeastern Turkey is an example of a landslide or rockslide lake. 4. Karst lakes. Description: karst lakes are formed in karst landscapes where soluble rocks such as limestone or dolomite are dissolved by water, creating sinkholes and depressions that may fill with water. Example: Lake Agurdur, located in the southwestern part of Turkey, is associated with karstic features. 5. Volcanic lakes. Description: volcanic lakes are formed in volcanic craters or calderas, often resulting from volcanic activity. These lakes may have unique features related to their volcanic origin. Example: Lake Nemrut, situated in a volcanic caldera in eastern Turkey, is an example of a volcanic lake. 6. Alluvial or fluvial lakes. Description: alluvial or fluvial lakes are formed by the accumulation of sediment carried by rivers or streams. Deltas or areas with slow-moving water can create depressions that become lakes. Example: Lake Manyas, located in northwestern Turkey, is an example of an alluvial lake formed by the Büyük Menderes River. 7. Anthropogenic or reservoir lakes. Description: anthropogenic or reservoir lakes are created by human activities, often through the construction of dams for purposes such as water supply, hydropower, or flood control. Example: the Ataturk Dam reservoir on the Euphrates River forms a large anthropogenic lake in southeastern Turkey. Understanding the formation processes of lakes in Turkey provides insights into their geological history and environmental characteristics. Each type of lake has unique features that contribute to the country's diverse landscape. Lake Hazar. Location: Lake Hazar is located in the eastern part of Turkey, near the city of Elazığ. Origin: it is a tectonic lake that formed in a depression created by tectonic forces. Tectonic setting: Lake Hazar is situated in a region where the Anatolian and Arabian plates interact. The tectonic activity in this area has led to the formation of grabens, which are elongated, fault-bounded blocks of the Earth's crust. Lake Hazar is located in one of these grabens, and it is surrounded by fault lines. Characteristics: Lake Hazar is known for its scenic beauty, and it is a popular destination for local tourism. The lake's water is relatively fresh compared to some other lakes in the region. Formation of a tectonic lake. The formation of a tectonic lake involves several geological processes. 1. Tectonic forces. Tectonic lakes are typically formed in regions where tectonic plates interact. These interactions can lead to the creation of faults, fractures, and basins in the Earth's crust. 2. Faulting and graben formation. As tectonic forces cause the Earth's crust to deform, faults may develop. In some cases, the crust can stretch, creating a depression or basin known as a graben. This is a block of the Earth's crust that has dropped between two fault lines. 3. Depression filling with water. The graben or depression created by faulting may fill with water over time. This can occur through various processes, including precipitation, runoff from surrounding areas, and inflow from rivers or streams. 4. Endorheic characteristics. Tectonic lakes are often endorheic, meaning they have no outlet to the sea. The water that enters the lake typically remains within the basin, leading to unique hydrological and ecological characteristics. 5. Salinity and characteristics. The specific characteristics of a tectonic lake, such as salinity, depend on the geological and hydrological conditions of the region. Some tectonic lakes, like Lake Van, may have higher salinity due to factors such as evaporation and limited freshwater input. In summary, tectonic lakes in Turkey, like Lake Hazar, are formed in regions where tectonic forces create gravens or basins, and these depressions are subsequently filled with water, resulting in the formation of a lake. The specific features and characteristics of each tectonic lake are influenced by the geological conditions of the region. Karstic lakes in Turkey are formed in regions characterized by karst topography, where soluble rocks such as limestone, dolomite, or gypsum are dissolved by water, creating distinctive landforms such as sinkholes, caves, and underground drainage systems. Here are a couple of examples of karstic lakes in Turkey. Lake Agirder. Location: Lake Agirder is located in the Isparta province in southwestern Turkey. Karstic characteristics: the surrounding region has karstic features, and the lake itself is influenced by the karst landscape. Karstic formations in the area contribute to the water supply of the lake. Lake Beyşehir. Location: Lake Beyşehir is situated in the Konya province in central Turkey. Karstic characteristics: the lake is influenced by the karstic features of the region, with underground drainage systems and the presence of karstic springs contributing to the lake's water balance. Formation of karstic lakes. 1. Karst topography. Karstic lakes are associated with karst topography, which is formed by the dissolution of soluble rocks, usually limestone or dolomite. Rainwater, slightly acidic due to dissolved carbon dioxide, reacts with the soluble rock, creating underground cavities and conduits. 2. Sinkholes and caves. As the dissolution process continues, sinkholes and caves may develop in the landscape. These features provide pathways for water to flow underground. 3. Underground drainage. Water from precipitation or surface runoff enters the underground drainage system created by the karst processes. This network of conduits directs water beneath the surface. 4. Emergence in lakes. The underground water may resurface at certain points, forming karstic springs or contributing directly to the feeding of lakes. These lakes are often characterized by clear water and may exhibit unique ecological features. 5. Karstic springs. Karstic lakes may receive water from karstic springs, where groundwater emerges at the surface. The water from these springs can be a significant source for maintaining the water levels in the lakes. Karstic lakes in Turkey, shaped by the dissolution of soluble rocks and the intricate underground drainage systems characteristic of karst topography, contribute to the country's diverse hydrological and geological landscape. Turkey, due to its diverse topography and climatic conditions, does not have extensive glacial features like some other regions with colder climates. Glacial lakes, which typically form in areas once covered by glaciers during the Pleistocene epoch, are more common in alpine and polar environments. However, there are some lakes in Turkey that have been influenced by glacial processes, particularly in the northeastern part of the country. Here's an example. Lake Sldr. Location: Lake Sldr is located in the Ardahan province in northeastern Turkey, near the border with Georgia. Glacial characteristics: while the lake itself is not directly formed by glacial activity, the region has been influenced by glacial processes during the Pleistocene epoch. The landscape, including the presence of moraines, indicates past glacial activity. Formation of glacial lakes. 1. Glacial activity. Glacial lakes are typically associated with the activity of glaciers during the Pleistocene epoch. Glaciers are large, slow-moving masses of ice that carve valleys, create moraines, and shape the landscape. 2. Moraines. As glaciers move, they pick up rocks and debris. When the glacier melts or retreats, it deposits this material along its edges, forming moraines. Moraines can act as natural dams, blocking rivers and creating depressions that may later become glacial lakes. 3. Meltwater. Glacial lakes are often fed by meltwater from glaciers. As the glacier melts, the water collects in depressions, forming lakes. These lakes can vary in size and shape, and their characteristics are influenced by the geology of the region. 4. Pleistocene legacy. Even if the glaciers have retreated, their influence on the landscape remains. Glacial moraines, erratic rocks, and other features may persist, indicating the past presence of glaciers. While Lake Sldr in Turkey is not a direct product of recent glacial activity, its location in a region influenced by Pleistocene glaciation illustrates the historical legacy of glaciers in shaping the landscape. It's important to note that glacial features are more pronounced in regions with higher latitudes and elevations, where glaciation was more extensive during the Pleistocene. Volcanic lakes in Turkey are formed within volcanic craters or calderas, often as a result of volcanic activity. Turkey has several volcanic regions, and lakes within these areas may exhibit characteristics associated with volcanic processes. Here's an example of a volcanic lake in Turkey. Lake Nemrut. Location: Lake Nemrut, also known as Nemrut Gölü, is situated in the caldera of Nemrut volcano in eastern Turkey, near the town of Tatvan. Volcanic characteristics: the lake occupies the caldera of an ancient volcano, and its formation is directly linked to past volcanic activity. The surrounding landscape includes remnants of volcanic features such as lava flows and volcanic cones. Formation of volcanic lakes. 1. Volcanic caldera or crater. Volcanic lakes are often found within the calderas or craters of volcanoes. A caldera is a large, circular depression that forms following a volcanic eruption, and it may fill with water over time. 2. Volcanic activity. The formation of volcanic lakes is closely tied to the volcanic history of the region. Volcanic eruptions can create depressions in the landscape, and these depressions may later become filled with water. 3. Crater lakes. Some volcanic lakes are located within the craters of active or extinct volcanoes. These lakes can vary in size and depth, and their water levels may be influenced by the geothermal activity beneath the surface. 4. Hydrothermal features. Volcanic lakes may exhibit hydrothermal features, such as hot springs or fumaroles, indicating the presence of geothermal activity. This can influence the temperature and chemistry of the lake water. 5. Tectonic setting. The location of volcanic lakes is often influenced by the tectonic setting of the region. In areas with active tectonic processes, volcanic activity may be more common, leading to the formation of volcanic lakes. Lake Nemrut, being located within the caldera of Nemrut volcano, exemplifies the formation of a volcanic lake in Turkey. The unique geological history and features associated with volcanic activity contribute to the distinctive characteristics of such lakes in the region. Natural dam lakes in Turkey are formed when natural barriers, such as landslides, rockfalls, or other geological events, obstruct the flow of rivers or streams, creating impoundments. Here's an example of a natural dam lake in Turkey. Lake Karagöl. Location: Lake Karagöl is located in the northeastern part of Turkey, near the town of Savsat in the Artvin province. Formation: the lake was formed by a landslide that created a natural dam along the Barhol River. The landslide occurred in the early 20th century and blocked the river, leading to the formation of Lake Karagöl. Formation of natural dam lakes. 1. Geological events. Natural dam lakes are typically the result of geological events such as landslides, rockfalls, or other processes that obstruct the normal flow of rivers. 2. Landslides. Landslides can occur when a mass of rock, soil, or debris moves down a slope, blocking a river or stream. This natural barrier then acts as a dam, impounding water and forming a lake. 3. Rockfalls. Similar to landslides, rockfalls involve the downward movement of rocks that can obstruct river channels. The accumulated rocks create a barrier, leading to the formation of a natural dam lake. 4. River obstruction. The obstruction of a river's flow, whether by landslides, rockfalls, or other geological processes, creates a temporary or permanent barrier. Water accumulates behind the barrier, forming a lake. 5. Impounded water. The impounded water behind the natural dam can vary in depth and size, depending on the volume of water flowing into the obstructed area. 6. Geological characteristics. The geological characteristics of the region, such as the type of rock, slope angles, and tectonic activity, play a crucial role in the occurrence of natural dam lakes. Lake Karagöl, formed by a landslide that acted as a natural dam, showcases how geological events can influence the creation of such lakes in Turkey. These lakes often have unique characteristics and can become valuable features for local ecosystems and tourism. Natural dam lakes, formed by natural barriers like landslides or rockfalls, can be classified based on different criteria. Here's a classification of natural dam lakes. Number 1. Formation mechanism. Landslide dammed lakes. Description: formed by landslides that block river valleys, creating impoundments. Example: Lake Karagöl in Turkey. Rockfall dammed lakes. Description: result from the accumulation of rocks that obstruct river channels. Example: Potrerillos Dam in Argentina. Glacial dammed lakes. Description: created by glacial activity, where moraines or ice block river valleys. Example, Lake Palcacoca in Peru. Number 2. Geographical location. Mountainous region lakes. Description, commonly found in mountainous areas with steep slopes and the potential for landslides. Example, Lake Safed Ko in Pakistan. Highland lakes. Description, situated at higher elevations, often associated with glacial activity. Example, Lake Tso Moriri in India. Number 3. Hydrological characteristics. Intermittent lakes. Description, lakes that may exist temporarily, with water levels fluctuating based on the status of the natural dam. Example, some small landslide dammed lakes. Permanent lakes. Description, lakes with more stable water levels, where the natural dam persists over time. Example, Lake Urmia in Iran, historically had a natural dam. Number 4. Size. Large natural dam lakes. Description, extensive bodies of water with significant storage capacity. Example, Lake Waikaramona in New Zealand. Small natural dam lakes. Description, relatively smaller lakes resulting from local geological events. Example, some small landslide dammed lakes in mountainous regions. Number 5. Ecological impact. Dynamic ecological systems. Description, lakes that experience changes in size and ecological dynamics due to the intermittent nature of the natural dam. Example, some intermittent landslide dammed lakes. Stable ecological systems. Description, lakes with relatively stable ecological conditions due to a persistent natural dam. Example, some permanent natural dam lakes. Number 6. Human interaction. Touristic natural dam lakes. Description, lakes with tourism potential due to their scenic beauty and unique formation. Example, some natural dam lakes in tourist destinations. Remote or inaccessible natural dam lakes. Description, lakes in less accessible areas with limited human interaction. Example, remote glacial dammed lakes in polar regions. Alluvial dam lakes. Definition, alluvial dam lakes are formed when sediments, alluvium, carried by a river or stream accumulate and create a natural dam, obstructing the flow of water and forming a lake behind it. Formation process. Sediment deposition, rivers transport sediments downstream, and in certain areas, the flow velocity decreases. Alluvial accumulation, the reduced flow velocity causes the deposition of sediments, forming an alluvial dam across the river channel. Lake formation, the accumulated sediments create a barrier that restricts the flow of water, leading to the formation of a lake or reservoir behind the dam. Characteristics of alluvial dam lakes. Temporary nature, alluvial dam lakes can be temporary and dynamic, especially in areas with variable sediment transport. Sensitivity to changes in river flow, sediment load, or other environmental factors can affect the stability and existence of these dams and lakes. Ecological impact, these lakes can create unique habitats for flora and fauna, and their dynamic nature may contribute to local biodiversity. It's essential to note that the term alluvial dam lakes may not be a standardized or widely used term in the scientific literature, and its interpretation might vary based on regional or local contexts. If you have a specific context or location in mind, providing more details would help in giving a more accurate and tailored response. Landslide dam lakes. Landslide dam lakes are formed when a landslide obstructs the flow of a river or stream, creating a natural dam and impounding water upstream. These lakes are often temporary and can pose hazards such as sudden dam breaches or outburst floods. Here's an overview. 1. Formation process. Landslide occurrence. A landslide occurs in a mountainous or hilly area, causing rocks, soil, or debris to rapidly move down a slope. River obstruction. The landslide material obstructs a river or stream, creating a natural dam across the channel. Water impoundment. Water accumulates upstream of the landslide, forming a lake or reservoir. 2. Characteristics. Dynamic nature. Landslide dam lakes can be dynamic and may change in size and stability over time, influenced by factors such as erosion, weathering, and additional landslides. Sensitivity to conditions. These lakes are sensitive to changes in upstream conditions, including rainfall, seismic activity, and ongoing slope instability. Hazard potential. Landslide dam lakes pose a potential hazard due to the risk of dam breaches or outburst floods, especially if the dam is unstable. Vajont Dam, Italy, 1963. While not a natural dam, the Vajont Dam disaster resulted from a landslide into the reservoir, causing a massive wave that overtopped the dam and led to catastrophic flooding downstream. 4. Hazards and management. Outburst floods. Landslide dam lakes can pose a threat if the dam fails. Outburst floods can result in downstream flooding, with potentially devastating consequences for communities in the path of the floodwaters. Early warning systems. Monitoring and early warning systems are crucial for identifying signs of dam instability and providing timely alerts to downstream populations. Landslide dam lakes highlight the complex interactions between geological processes, natural hazards, and the potential impacts on the environment and communities. Understanding their formation and behavior is essential for assessing and mitigating associated risks. In Turkey, there are several volcanic dam lakes that have formed as a result of past volcanic activity. One notable example is Lake Nemrut, located in the eastern part of the country. Here's information about Lake Nemrut. Lake Nemrut. Location: Lake Nemrut, also known as Nemrut Gölü, is situated in the caldera of Mount Nemrut in the Tatvan district of Bitlis province, eastern Turkey. Formation: the lake was formed within the volcanic caldera, which is the result of past volcanic activity associated with Mount Nemrut. Volcanic features: Mount Nemrut is a stratovolcano, and the lake is located in its summit crater, which collapsed during a volcanic eruption, creating the caldera. Geothermal characteristics: the region around Lake Nemrut may exhibit geothermal features, including hot springs, due to the residual volcanic activity in the area. Landscape: the landscape around Lake Nemrut is characterized by volcanic cones, lava flows, and other volcanic landforms. Other potential examples. While Lake Nemrut is a prominent example, there may be other smaller volcanic dam lakes in Turkey, especially in regions with a history of volcanic activity. However, specific details about other volcanic dam lakes in Turkey may depend on ongoing geological research and exploration. Geological context. Turkey is part of the East Anatolian Rift Zone, a region with significant tectonic and volcanic activity. Volcanic features and landforms are found in several parts of the country, especially in eastern Turkey. Understanding the geological context of these regions is essential for studying volcanic dam lakes and their associated features. Conservation and research. Given the unique geological and ecological characteristics of volcanic dam lakes, conservation efforts and ongoing research are crucial. Understanding the stability of volcanic structures, monitoring geothermal features, and preserving the unique ecosystems associated with these lakes contribute to their sustainable management. It's recommended to refer to updated geological studies and local authorities for the latest information on volcanic dam lakes in Turkey. As of my last knowledge update in January 2022, there isn't specific information about coastal dam lakes in Turkey. However, I can provide a general understanding of coastal dam lakes and their potential relevance to Turkey's coastal regions. Coastal dam lakes. Coastal dam lakes refer to bodies of water that are formed by the construction of dams along coastal areas. These dams may be built at the mouths of rivers, estuaries, or other coastal locations, creating impoundments of freshwater that mix with seawater. The construction of coastal dams can serve various purposes, including freshwater supply, flood control, agricultural irrigation, and even recreational use. Considerations for coastal dam lakes in Turkey. 1. Freshwater management. Coastal dam lakes can contribute to managing freshwater resources, especially in regions where rivers meet the sea. The controlled release of freshwater from these lakes can help maintain a balance between freshwater and saltwater in estuarine ecosystems. 2. Agriculture and irrigation. In coastal areas where agriculture is a significant industry, coastal dam lakes can be designed to provide a controlled and sustainable supply of freshwater for irrigation. 3. Environmental impact. The construction of dams in coastal areas can have environmental implications, affecting the ecology of estuarine zones and potentially impacting marine life. Proper environmental impact assessments are essential. 4. Tourism and recreation. Well-designed coastal dam lakes may provide opportunities for tourism and recreational activities, such as boating, fishing, and bird watching. Specific examples in Turkey. To obtain information about specific coastal dam lakes in Turkey, it would be advisable to refer to more recent and local sources, such as government publications, environmental agencies, or academic research. Local authorities and water management organizations in Turkey may have updated information on coastal dam projects and their status. Lakes with mixed origins, often referred to as polymictic lakes, can result from a combination of geological processes such as tectonic and volcanic activity. Here's a general overview. Polymictic lakes. Polymictic lakes are characterized by frequent mixing of their water layers, typically due to the influence of various factors, including wind, temperature changes, and the introduction of different water sources. These lakes may exhibit a combination of origins, such as tectonic, volcanic, glacial, or other geological processes. Formation of polymictic lakes with mixed origins. 1. Tectonic activity. Tectonic processes, such as the movement of Earth's plates, can create depressions in the landscape that become lake basins. Faults or rift zones resulting from tectonic activity may contribute to the formation of lake basins. 2. Volcanic activity. Volcanic activity can create lakes within calderas, craters, or other volcanic features. Lava flows may block river valleys, forming natural dams and leading to the creation of volcanic lakes. 3. Glacial influence. Glacial processes, such as the carving of valleys and deposition of glacial sediments, can contribute to the formation of lake basins. Meltwater from glaciers may feed into lakes, affecting their water composition. 4. Hydrological factors. Rainfall, snowmelt, and runoff from surrounding areas can influence the water balance of polymictic lakes. Wind-induced mixing, especially in shallow lakes, can result in the vertical mixing of water layers. Examples in Turkey. While I don't have specific examples of polymictic lakes with mixed tectonic and volcanic origins in Turkey, the country's diverse geological landscape suggests the potential for such lakes. Regions with active tectonic and volcanic activity, such as the East Anatolian Fault Zone and volcanic areas in eastern Turkey, may host lakes influenced by multiple geological processes. For detailed information on specific lakes in Turkey with mixed origins, it's advisable to refer to geological studies, publications, or resources from local environmental agencies and academic institutions specializing in geology and hydrology in the region. Thank you for providing specific examples. It's helpful to have details on the geological origins of these lakes. Here's a brief overview. Agirder Lake, Kovada Lake, and Beyşehir Lake. 1. Agirder Lake. Origin, primarily formed through tectonic processes. Tectonic activity, the lake basin is associated with tectonic movements, potentially related to faulting or other geological processes. 2. Kovada Lake. Origin, tectonic and karstic in nature. Tectonic activity, similar to Agirder Lake, tectonic processes likely played a role in the formation of the lake basin. Karstic influence, karstic features, such as dissolution of soluble rocks, for example, limestone, may contribute to the lake's hydrology. 3. Beyşehir Lake. Origin, tectonic and karstic. Tectonic activity, the lake basin is likely associated with tectonic movements. Karstic influence, karstic processes, similar to Kovada Lake, may have influenced the lake's formation. Van Lake. Origin, tectonic and volcanic. Tectonic activity, the lake basin is associated with tectonic processes, potentially related to the complex tectonic setting in the region, such as the collision between the Arabian and Eurasian plates. Volcanic influence, volcanic activity, including the presence of nearby volcanic features, contributes to the geological history of Van Lake. Significance. Understanding the geological origins of these lakes provides insights into the diverse geological history of Turkey. Tectonic and karstic processes are common contributors to the formation of lakes in regions with complex geological settings. It's important to note that geological studies and ongoing research can further enhance our understanding of these lakes and their dynamic geological processes. For the most current and detailed information, referring to geological publications, research articles, or local geological surveys is recommended. The lakes in Turkey exhibit a diverse range of geological origins, shaping their unique characteristics and landscapes. Here is a descriptive text categorizing these lakes based on their geological formations. Tectonic lakes. 1. Tuz Lake, situated in a tectonically active region, Tuz Lake reflects the influence of geological processes, possibly related to faulting or tectonic movements. 2. Sapanca Lake, the tectonic forces that have shaped the region contribute to the formation of Sapanca Lake, resulting in a picturesque lake surrounded by hills. 3. Iznik Lake, tectonic activity is evident in the creation of Iznik Lake, where the geological history is intertwined with the surrounding landscape and morphology. 4. Manyas Lake, Manyas Lake, with its rich biodiversity, owes its existence to tectonic processes that shape the topography of the area. 5. Border Lake. The tectonic origins of Border Lake play a crucial role in its formation, providing a habitat for various bird species. 6. Eber Lake. Eber Lake, influenced by tectonic activities, stands as a serene expanse reflecting the geological history of its surroundings. 7. Akdamar Lake. Tectonic forces have contributed to the creation of Akdamar Lake, giving rise to a significant freshwater resource. 8. Hazar Lake. Nestled in a tectonically active region, Hazar Lake exhibits the geological imprint of seismic forces, creating a scenic lake environment. Volcanic lakes. 1. Nemrut Lake. Formed within the caldera of Nemrut volcano, Nemrut Lake is a striking example of a volcanic lake, showcasing the impact of volcanic activity on the landscape. 2. Ugal. As a volcanic lake, Ugal mirrors the geological legacy of past volcanic events, contributing to its unique ecological and geological features. 3. Meek Lake. Meek Lake, surrounded by volcanic terrain, bears witness to the volcanic processes that shaped its basin. 4. Guljuk Lake. Nestled in a volcanic setting, Guljuk Lake is a testament to the region's volcanic history, with its scenic beauty and geological significance. Karstic lakes. 1. Salda Golu. Shaped by karstic processes, Salda Golu reflects the dissolution of soluble rocks, resulting in its crystal-clear waters and unique geological features. 2. Kestel Golu. Karstic influences contribute to the formation of Kestel Golu, creating a landscape shaped by the dissolution of limestone and other soluble rocks. 3. Karagol Golu. Karagol Golu showcases the geological impact of karstic processes, presenting a picturesque lake surrounded by karst terrain. 4. Xoran Golu. The karstic landscape of Xoran Golu is characterized by the dissolution of carbonate rocks, shaping the lake's topography. 5. Timruz Golu. Influenced by karstic features, Timruz Golu reflects the unique geological processes that have given rise to its scenic setting. 6. Akol. Akol, formed through karstic processes, stands as an example of the geological interaction between surface water and soluble rock formations. Glacial lakes. 1. Anal Gol. Anal Gol is indicative of a glacial origin, shaped by the erosive forces of glaciers that carve the landscape to form this reflective lake. 2. Kilimli Gol. Kilimli Gol, with its glacial origins, reflects the historical impact of glaciers on the region's topography. 3. Karagol. As a glacial lake, Karagol bears the imprint of past glacial activity, contributing to its scenic beauty. Mixed lakes. 1. Van Lake. With a combination of tectonic and volcanic influences, Van Lake stands as a mixed origin lake, showcasing the interplay of geological processes. 2. Agurdur Lake. Agurdur Lake is characterized by a mix of tectonic and karstic influences, resulting in a diverse geological landscape. 3. Kovada Lake. Shaped by both tectonic and karstic processes, Kovada Lake exemplifies the geological complexity of mixed origin lakes. 4. Sapanka Lake. While primarily tectonic, Sapanka Lake also exhibits characteristics influenced by other geological processes, presenting a mix of origins. Each of these lakes tells a geological story, reflecting the intricate processes that have shaped Turkey's diverse and captivating landscapes. Landslide lakes. 1. Torchum Lake. Formed as a result of a landslide, Torchum Lake reflects the geological consequences of mass movement, creating a unique landscape. 2. Sirah Lake. The presence of Sirah Lake highlights the impact of landslides on the formation of lake basins, contributing to the diverse geology of the region. 3. Abant Lake. Abant Lake, with its scenic surroundings, bears the influence of landslides in shaping the topography of the lake basin. 4. Yedigolar. 7 lakes. The lakes in the Yedigolar National Park are characterized by landslide origins, showcasing the interconnectedness of geological processes and natural beauty. 5. Zenav Lake. Zenav Lake is an example of a lake formed by landslides, emphasizing the dynamic geological forces that have shaped Turkey's landscapes. Coastal lakes. 1. Büyük Çekmece Lake. Located along the coast, Büyük Çekmece Lake exemplifies the influence of coastal processes on the formation and dynamics of the lake. 2. Küçük Çekmece Lake. Küçük Çekmece Lake, situated near the coast, reflects the coastal geological context, contributing to the environmental richness of the region. 3. Turkos Lake. Turkos Lake, positioned near the coast, showcases the interplay of geological and coastal factors, forming a vital part of the coastal ecosystem. 4. Durusu Lake. also known as Lake Durusu, it exhibits the characteristics of a coastal lake, reflecting the geological features associated with coastal regions. 5. Akdamar Lake. Akdamar Lake, located in a coastal setting, is influenced by the proximity to the sea, contributing to its ecological significance. Volcanic lakes. 1. Ursic Lake. Ursic Lake stands as a testament to the volcanic origins in the region, showcasing the impact of past volcanic activity on the landscape. 2. Nazik Lake. Nazik Lake, formed within a volcanic context, reflects the geological legacy of volcanic processes that have shaped the region. 3. Hassel Lake. Hassel Lake exemplifies the influence of volcanic activity on lake formation, contributing to the unique geological features of the area. 4. SLDR Lake. Positioned in a volcanic region, SLDR Lake bears the imprint of past volcanic processes, creating a distinctive geological environment. 5. Bok Lake. Bok Lake showcases the influence of volcanic origins, adding to the geological diversity of Turkey's lake landscapes. Alluvial lakes. 1. Mogan Lake. Formed through alluvial processes, Mogan Lake highlights the role of sediment deposition in shaping the lake basin. 2. Ymir Lake. Ymir Lake, with its alluvial origins, is a testament to the deposition of sediments and the geological history of the surrounding area. 3. Bafa Lake. Bafa Lake reflects the influence of alluvial processes, contributing to the formation of the lake basin and the ecological richness of the region. 4. Samisi Lake, also known as Lake Samisi, it exemplifies the impact of alluvial factors on lake formation, shaping the geological characteristics of the area. 5. Koysages Lake. Koysages Lake, formed through alluvial processes, showcases the dynamic interplay of sedimentation and geological evolution. Each of these lakes, shaped by distinct geological processes, contributes to the rich tapestry of Turkey's landscapes, providing unique habitats and scenic beauty. Turkey is home to numerous artificial lakes, primarily formed by the construction of dams for various purposes such as water storage, irrigation, hydroelectric power generation, and flood control. These dam lakes contribute significantly to the country's water resources, energy production, and agricultural activities. Here are some notable artificial lakes, dam lakes, in Turkey. 1. Ataturk Dam Lake. Location: Euphrates River, southeastern Anatolia. Purpose: irrigation, hydroelectric power generation, flood control. Key features: one of the largest artificial lakes in Turkey, created by the Ataturk Dam. 2. Kaban Dam Lake. Location: Euphrates River, eastern Anatolia. Purpose: irrigation, hydroelectric power generation. Key features: the reservoir created by the Kaban Dam, serving as a major water resource and power generation source. 3. Karakaya Dam Lake. Location: Euphrates River, eastern Anatolia. Purpose: irrigation, hydroelectric power generation. Key features: the reservoir formed by the Karakaya Dam, contributing to water management and electricity production. 4. Hurlfanal Dam Lake. Location: Sakarya River, central Anatolia. Purpose: irrigation, flood control, recreation. Key features: Hurlfanal Dam creates a lake along the Sakarya River, supporting agricultural activities and providing a recreational area. 5. Beyşehir Dam Lake. Location: Konya Province, central Anatolia. Purpose: irrigation, water storage. Key features: the reservoir formed by the Beyşehir Dam, contributing to regional water needs. 6. Altınkaya Dam Lake. Location: Yeşilırmak River, Black Sea region. Purpose: irrigation, hydroelectric power generation. Key features: Altınkaya Dam Lake is created by the Altınkaya Dam and serves agricultural and energy production purposes. 7. Gölcük Dam Lake. Location: Sakarya River, western Anatolia. Purpose: irrigation, water storage. Key features: the reservoir formed by the Gölcük Dam supports agricultural activities in the region. 8. Demirköprü Dam Lake. Location: Gediz River, Aegean region. Purpose: irrigation, water supply. Key features: the Demirköprü Dam creates a lake along the Gediz River, contributing to water management. 9. Karakauran Dam Lake. Location: Antalya Province, Mediterranean region. Purpose: irrigation, water supply. Key features: the Karakauran Dam forms a reservoir supporting agricultural and water supply needs. #10. Samildir Dam Lake. Location: Ankara Province, Central Anatolia. Purpose: water supply, recreation. Key features: the Samildir Dam Lake serves as a water resource for Ankara and offers recreational opportunities.